Okay, let us see this one. It's a nice one also. A stone is projected vertically upwards from the top of the cliff 10 meters high. I think it's 10 meters, this is the cliff. After 3 seconds, it passes the edge of the cliff. So after 3 seconds, it passes the edge of the cliff. Meaning, if I project it up and passes the edge of the cliff, it means that it was falling on its way down. Find the speed of projection in simple terms. Whenever they ask the speed of projection, they are asking the initial speed at which you projected that object. Now, to do a simple sketch, this is now going to be, it's projected upwards like that. Then after 3 seconds, it's going to make that there. Now, 3 seconds, they are telling us that it passes the edge of the cliff. So this is our edge of the cliff. So meaning here, at this point here, our x is going to be 0 because it does not cover the distance. It's there and then it comes back. So distance covered, so it's like moving forward and then coming back. One step, then going back 1 step. Same magnitude, we have not covered any distance. So this is the point we are talking about. So here, they're asking us for the initial, which we don't know. But the time taken for it to come back here is 3 seconds at that point there. So, the speed of projection, what do we have? We have the distance. Now it's starting here, because it's going up there, our A is going to be negative B. And the don't give us our U, we take 9.8. So now in our part A, we know that our S is equal to T plus our half A T squared. So now, this one is 0. At this point, the distance covered is going to be 0 because it's going and then it's coming back at that point where it started. So, the distance covered is 0. Our initial is what we are looking for. The time is 3. Then, because acceleration is negative, and we put this negative here, it affects that. I have 9.8. This is 9.8 acceleration, the B. Meters, of course, per second. Then time is 3 squared. And so simplifying it from here, you can get the answer straight away. So this would be 3u equaling to, now when I get this beside this one becomes 4.9 into 9. And so our u will be, it's going to be 14.7 meters per second. That would be our u. Then part B, the speed when it hits the ground. Now the speed when it hits the ground, that means that when it's coming to hit the ground, it's going to go from there, and then I think that's where it will hit the ground. So they're asking for this V, this velocity. But remember, the object is falling, we said velocity is negative. So the distance that now here, our distance is covered now from here, so it's going below where it started. Whenever it's going below where it started, now our distance is covered from here to here. So from here up to here, the distance is covered. Our S here is going to be now negative 20 meters because it's below the initial, or below the point, initial point of projection. Whenever the body is going to the initial point of projection, it's negative. So R is going to be negative, the acceleration is also going to be negative. So what do we have? We have the distance, we have the initial, we have the time, and then the speed at which it sits is going to hit the ground. So from there, what are you going to use? Do we have the time? I don't think we have the time from there. So you can say our V squared, because we need this. We have our initial, we have the acceleration, and we have the distance. So there you can also use the third equation. V squared equal to U squared plus 2AS. Remember, it was whenever it's fast, the moment it's going upwards. So that would, our graph is going to be negative. Unless it's just falling, that's when we take it positive. So this will be negative V squared equal to our U, which is 14.7 squared, then minus 2 into, this is 9.8, then our S So this is negative, please put that in mind, negative. So the negative, when this negative comes here, that's when we have that. The distance is going to be negative 20. Why am I using this? Because we don't have the time from here to here. We don't have the time. So I look for the equation which has S, V, and U. So there might be, so from here you can give us the answer at once. So you'll be having the answer here is 24.659 meters per second. That will be that. Then here, the time when it's 10 meters above the cliff. So now here, I'm going to do a simple sketch. So this is our ground. So this is our cliff here. Remember our cliff is 10 meters high. So they're asking us the time when this ball maybe is the height from here. When it is 10 meters above the cliff. So this time is what we are looking for. So from there, I start our S is 10 from here. So our U, we have our U already from here. Our U is 14.7. Then they're asking for what? The time they're asking for time. We have our acceleration. Instead, our acceleration is going to be negative d, which will be negative 9.8. So we have this, we have this, we have this. So I'm going to use my S equaling to t plus a half ft squared. Putting it here, now the distance is not from here to here is 10. So we have 10 equaling our u, which is into the time which you don't have, then minus, when I put this acceleration which is negative, I have a half, 9.8, then the t we are looking for. So this would be 10 equaling 2 for t, then minus 4.9 t squared. Taking everything this side, so we have t 4.9 t squared minus 14.7 t n plus 10 equaling to 0. Now from there, we use a bulldozer. Please show that you're using a bulldozer to get t. So from here, I start, I'm going to say my t will be minus b, which is negative 14.7 plus or minus square root of b squared, which is negative 14 minus 4 into a 4.9 and 10, the whole over 2 into 4.9. And so here, my t will be so t is 1.957, or t is 1.0446 seconds. So from there now, after, let us get some okay, after getting that now, I think we are, so the time, this, that. Then let us come to part D. What does part D say? Part D say the time when it's 5 meters above the ground. 5 meters above the ground. Now, to draw that sketch is going to be, so this is the, remember this is our cliff. Our cliff here. We say from here it's going to be 20 meters. That's the cliff. Now they're asking us 5 meters above the ground. So 5 meters above the ground, if this is from here up here is 15. So in simple terms, they are asking us that this stone had covered now 15 meters, because for it to be 5 meters above the ground, so from here, that's when we are going to be having 5 meters above the ground. So in simple terms, they are asking us, find the time when this stone had covered. Now this is going to be our stone here. It's going to come, or the object is going to come just when it's 15 meters above the ground. So the 15 meters above, 5 meters above the ground. So it means it has just gone 15 below the initial. So meaning here, the initial here, it has gone just 15 below the projection point. So if they want us to get the time, so here we have, so we have at this point we have our S as negative 15 meters. Why? Because it's below the point of projection. Our U is going to remain, our U, the initial speed, 14.7 meters per second. Then what else do we need? We need the time is what we are looking for. Then our acceleration due to gravity is going to be 9.8. So using our formula, our S equaling to UT plus a half AT squared. Our S here is going to be negative 15 equaling to our U, 14.7 into the time we are looking for. A is negative, so negative a half, 9.8, then T squared. And so this would be negative 15 equaling to 14.7 T, then minus 4.9 T squared. Taking everything this side, we have 4.9 T squared minus 4.7 T, then minus 15 equaling to 0. And instead of there, we can't get accurate truths. So what do you use? You come and state your bulldozer to be negative of 14.7 plus or minus square roots of negative 14.7 squared minus 4SC. Our A is 4.9, then C negative 15. That's how it's our bulldozer is going to be. Then the whole time is, this is divided all of this, 4.9 our A. And so the time you are getting there is going to be so here I'm getting 3.8, and I'm giving it one decimal place. Then the other is negative. The other is negative 0.8. So therefore, our T here will be 3.8 seconds. So means that for it to be this, it needs 3.5 seconds. Meaning just from here up to here, it's going to use 0.8, because it's so that from here up to here it's using 3 seconds. Then from here up to here, it's using just 0.8 seconds. So meaning the speed towards traveling is very high. As you can see, it's very, very high. Okay. As members, that's how we handle that. I wish you well.